So just to introduce myself, my name is Putu Mahesa from PCD class with student ID 2215015086. Uh, and today I will explain about my demo project. Okay, station, share screen. Okay, okay. Before I will explain my code, maybe I will showing the layout for the first. Okay. Okay, for demo, I will use the cameraman in the lineup. We the cameraman first. Okay. Uh, in my demo project, I have a image negative filter. This where is rotate 90 derajat, 180 derajat, 270 derajat. Okay, like this. Okay. Next is image brightness. Okay. Then image mirror, image flip, image horizontal vertical. And after that, I have image logarithmic, image threshold, zoom out, zoom in, image shrinking, image translation, and the last is blend. Okay, we'll blend Lena and the cameraman. Blend image. Okay, the view like this. Okay, okay. Uh, After that, we go to the explain about the code. Okay, the first code is the negative image. For the negative image, the filter produces a negative version of the input image by inverting the colors. This is done by reducing the RGB value of each RGB value of each pixel from 255. The maximum value for an 8-bit color channel that's creating a negative effect. Okay, this is okay. Next is image rotate. For the image rotate, I have a 3 rotation window. Create with the difference algorithm to the rotate the image by 90, 180, and the last is 270. Okay. In the 90 degrees rotation, the output image is created with the dimension swap between the width and height of the input image. Okay. For each pixel in the output image, the pixel value is taken from the input image according to the desired rotation direction. B. Take it clockwise or anti-clockwise at always anti-clockwise. Okay, for the 180 degrees rotation, the output image has the same size as the input image, and each pixel is taken from the input image by reversing its pixel coordinates, whereas in 270 degrees rotation, the output image has the dimension swept between the width and height of the input image, and the pixel values are taken from the input image in the opposite side or to the itu 90 90 degrees rotation. Also based off the desired rotation direction. Using the approach, all three rotation can be performed by modifying and rearranging the pixel position from the input image to the output uh, image according to the desired rotation. Okay, the next is the plus-minus function. Okay, the plus-minus function modify the color intensity value of the each pixel in the input image by adding of subtracting a constant value. Okay, constant value. It begins by answering that create a new image object with the same dimension. I'm sorry. It's begin by answering that the image is in RGB color. RGB mode if the color depth is not already 24-bit. Then it create a new image object with the same dimension as the input for each pixel in the output image. The red, the five is the red, green, and blue component values. Red, green, and blue. From the input, okay, let's from the input. Yes, sorry. Next, it adjusts each core component adding the constant value, constants. So, yeah. So with value from the exceeding the maximum value is 255 or falling below the minimum is zero. Clipping. A clip, it is set to zero. After adjusting the color values, the function of the output image with the new RGB values, finally it will return modified image as the output. This process ensures that the color intensity of each pixel in array altered while maintaining the image of our approach. Okay, okay. Uh, the next is the flip function. The flip function, the input image horizontally, are vertically, and the last is diagonal or G. Based of the specific direction. Okay, this direction. Mm. Initially, it is that the image is in RGB color mode if the color deep 24-bit. Then it creates a new image object with the same dimension as the input, iterating over each pixel in the output image. And it determines the referral direction according to the provide direction value. If horizontal, vertical, if flip the image vertically in a similar manner, and the last is for G, the diagonal, it performs a diagonal flip by adjusting the pixel coordinate accordingly. After processing all pixel, the function checks the call depth value to determine the final call mode of the output image. If call depth is 1, We convert the output image to a one bit black and white image. If A, sorry, if A, it convert to an 8-bit grayscale image. Otherwise, the output image is in RGB color mode. Finally, as it is the modified image, the output, this process ensures that the input image is flipped according to the specific direction while maintaining the approach color mode. Okay. Next is image logarithmic. Okay, for the logarithmic function applies a logarithmic transformation to each pixel in the input image to enhance the contrast in the darker areas. Initially, it refines the red, green, and blue color component values for the each pixel. Okay, red, green, and blue. Then it applies a random transformation to each color component using the formula red sama dengan constant kali match log 10 is operasi logarithmic. Where the content value determine the degree of contrast values are within the valid range of 0 to 20, I'm sorry, 255 using the clipping technique, sorry, clipping technique. If any value exceeds 255 is set to 255, and if it's below 0, it's set to 0. This process effectively increases the contrast is in the darker parts of the image while preserving the overall image quality. Okay. The next is thresholding. For thresholding, we convert the image to the model grayscale. Okay, with the like this. Okay, just maybe thresholding is a technique used to convert color of graphical image into binary image, typical black and white, based on a specified threshold value. The process converting it is necessary, then creating a new image object with the same dimension as the input. That's the input. And everything over each pixel in the input image, the function compares the graphical intensity value of the each pixel with the threshold. If the intensity greater than or equal to the threshold or the output pixel is at a 255. This is white, and 0, this is black. Okay, the next is a blend image. For the blend image, we get the size of the small image, then determine the scaling factor to resize the second image with the discoding. After that, resize the second image while maintaining aspect ratio for discoding, and a new blank image to store the result with discoding. Get pixel data of the reside second image with discoding. Okay, and algorithm with this algorithm blend to the image pixel by pixel. For that, we have a convert the result image to space follower type. So yeah, I think this is a few still very Then, okay, okay. Maybe the next is zoom. Okay. The image zoom function performs zoom operation on the input image using big cubic interpolation. It calculates the size of the new output image based on the given scale in the output image. Sorry, given scale factor, create a new image object with the calculated size and iterates over each pixel in the output image. For the each pixel, it calculates the corresponding coordinate in the neighboring pixel to be used for big cubic interpolation and calculate the interpolation coefficients. The cubic interpolation is the performer for each color channel RGB and the result and combine into an RGB pixel value and showing the value are within the valid range of 0 to 250. Finally, the new RGB pixel is placed in the corresponding coordinate in the output image. This process effectively zoom the input image while maintaining image quality through a big enter. Okay, this this is to menghitung gambar. This is a make image output, the new output for the new ukuran yang baru juga. Okay, use okay to zoom the in the first big. The next is hitung koordinat pixel berdasarkan faktor skala dan bukan berdasarkan pixel tetangga yang digunakan untuk mengasah big kubik atau comparison interpolation big kubik. This, this is to the isi pixel output the hasil yang terus big kubik. After that is the konversi tipe warna. The color type, but this is optional. Okay, next is image string. Okay, we'll explain image string. Image string function perform a stringing operation on the input image using a simple interpolation method. It calculates the size of the new output image based on the vector, then it based on the git scale factor by multiplying the width and height of the input image by the scale factor. Then it iterates over each pixel in the output image, and for each pixel, calculate the correlating of the corresponding pixel in the input image by dividing the correct coordinate by the scale factor. After obtaining pixel coordinate in the input image, it identifies the pixel color value R, G, and B from the input image. Finally, it places the identified pixel color value at the corresponding coordinates in the output image. This was effectively stringing the input image file using a simple interpolation method to maintain image quality. Okay, that's the explain. Okay. The first to do image shrinking, the first is conversi gambar ke mode RGB, but this is optional. Okay, after that hitung ukuran gambar setelah shrinking. Okay, after that make a image output, a new output with the new size. Terus after that loop melalui step pixel, hitung coordinate pixel dalam gambar, menghitung, ambil warna, take a color picture, after that letakkan. Okay, the last is translation function. The text processor image function translate the input image horizontally and vertically based on the given offset value. It iterates through each pixel in the input image and calculate the new coordinate of the pixel after translation by adding the translation amounts tx for the x-axis and ty for the y-axis. This is okay. The original pixel coordinate. Then it checks if the new coordinates are within the boundaries of the output image. If so, it copies the pixel value from the input image to the output image at the new coordinate. After processing of pixel, the function returns the translate image object and as the final result. This process effectively moves the unreached image the specified direction by the given offset value. Okay, does that explain? Okay, for the to do translate image or translation image, uh, the first we have to take dimensi gambar, fixed dimension with height, image size. Then make apply to the menyimpan the save the picture. After that is translasi do translasi for the any pixel picture and hitung the new position for the any pixel. Okay, ketika gambar itu disebut okay. Okay, that's all for my the presentation. I'm so sorry because my English is not good, but I hope the share can bisa mengerti apa yang saya maksud. That's for all. Thank you so much. Thank you.